Recording in progress. I didn't touch anything, but someone did it for me, I guess. So now we can start, right? Okay, so I'm going to talk about VISSIM, which is a leading microscopic simulation tool developed by PTV Group. Building up a model is like creating a digital replica of the real world, where you connect the network elements with each other and with other objects to resolve conflicts or to add signalizations or other objects. You also need to add the demand, the volumes of vehicular traffic, public transport, cyclists, and pedestrians. After calibration and generating scenarios, you can investigate the interaction of all agents in the system, perform evaluations, and produce visualizations. In the next slides, let me show you a few of the new features and evaluations implemented into PTV VISSIM. Simple ITS tools and a very easy way to simulate intelligent transport system without the need for VisWeb or programming. These are available in VISSIM already, but now we have some additional buttons in the vertical toolbar and flyouts for comfortable configuration. The definition of the major flow is now combined with the two-phase actuated signal controller. The pedestrian crossing signal controller has been accessible through the context menu now, also with its button and a preview of the new objects to be placed. Railway crossing signal control with the automatic placement of the call and checkout detector, and ramp metering controller. This is a brand new in VISSIM, and it is based on the linear algorithm. Flyout offers parameters to set. Now I will jump to VISSIM, to a very simple network with few intersections, and I will show you these new functionalities. So let me jump to the pedestrian crossing. This is a link which is used as a pedestrian area for pedestrians from crossing this main street. And here on the vertical toolbar, on the left top corner of the network editor window, I have the option to choose create pedestrian crossing. When I move my cursor to the link, immediately I see the preview of the objects which can be generated by the tool. So I see here the conflict areas, I see the stop lines there, and I see also the detectors. And when I just confirm by clicking, it's there. So it's literally just one click to create a solution for a pedestrian crossing. You can imagine that like a pedestrian crossing with a button where if a pedestrian is detected or push the button, then it gets the green light. And the next one is a simple intersection with a major road and a minor road. And you can imagine a solution where for the minor road, the vehicles get a green signal only if there is a demand. So if a vehicle is detected. And you can do that very easily with by using define major flow. And here you can choose if you just want to set the conflict areas or create the two-stage controller or both of them. So I selected both, and then I just select my major road, and then I move my cursor into the middle of the intersection, and I confirm that all these conflict areas inside a circle belong to the intersection, and I get the preview of all objects which will be generated there. So the signal heads, the detectors, and the conflict areas. And then just I confirm that, and everything is there, just a few clicks. And the third option here, this is my main row as in the previous cases, and this link represents a link used by a tram or by a train. And I want to create a railway crossing here. So I choose this button, create railway crossing, and then I just specify the direction the train or the tram will use. And then after a few clicks, I get the preview of the objects to be placed there. So the signal heads and the checkout detector is here. And when I zoom out a little bit, you can see we have another detector here, which will be the calling detector. This one is placed automatically in distance of 200 meters. That is specified here. But you can move it then, which depends on the speed used by the trains and how much safety you need at that particular intersection. So I just confirm that. And I will switch to 3D. And we'll start a simulation. And you will see what happens. So the vehicles driving on the main road, they will be there in a few seconds. They have the green signal, and the pedestrians, they get the green signal when they are detected there after a few seconds of waiting, which is the minimum green for vehicles is considered, of course. And if there is no pedestrian, then the vehicles will remain the green signal. Let me move to the intersection with the major and minor road. So the black vehicle there is from the minor road. It has been detected and got the green signal. Afterwards, the major road get a green signal. And again, if a vehicle appears at the minor road and the minimum green time is over, then this minor road get the green signal. And let's move to the railway crossing. Now you see the tram is driving through, and afterwards the vehicles get a green signal again, and they will remain the green signal until the next tram or the train. And the train will trigger the change by activating the call out, the call in detector, and then later on will deactivate it by using the checkout detector. Let me go back to the presentation and to the next slide. Parking objects in VISSIM can be used to model any kind of curbside activities, including pickup and drop-off, loading bays, or parking itself. The basic components are parking lots, parking routes leading to the parking lots, and a tool that allows to generate several parking spaces at once called car park creator. Later on, I will show that tool as well. If you need to manage parking in reverse for loading bays, and it does not matter if it's a logistics center or a busy street with many small local shops, take a look at the example with track reversing, which is available within the installation. Now let me go to VISSIM again for simple demonstration how the reversing look like. So I will start the simulation, switch to 3D, and you'll see vehicles coming in and then reversing to the loading bay, then staying there for predefined time, and then leaving back on the original route. So how this looks in the model, you can say this is the main route using by the vehicles, and we have one parking route leading to this parking lot. And for this parking lot, you can specify the parking direction. In this case, it's forward in and reverse out. And then you can specify the direction change time distribution, which is 60 seconds in this case. So actually this time distribution here for the direction change is used as the parking time, as the time which is needed to load or to unload the vehicle there. And the parking time itself on the parking route leading to the parking lot is set just very small. Maybe that's not realistic. Maybe it should be a few seconds just to change the gear and then starting going backwards. Let me show you another very simple model, but this time not in the current version 2022, but in the version 2023, which is in preparation. But as an appetizer, I will show you the car park create a tool. So when I click on this button here, create car park, and then on the link, I can create several parking spaces at once very easily. Here I can specify if I want to have it on both sides or left or right only. There are a few other parameters to set, but what is new and will come with maybe the next or the second next service pack into VISSIM 2022 and then with VISSIM 23 as well, that you can specify the parking rate for reverse here. And if I put 50% here, then it means I want to have 50% of vehicles parking in forwards and 50% of them parking in reverse. And I just confirm it, and you can see that all the objects have been created. The links and or the connectors leading to the parking spaces and some other necessary objects. And let me show you here on the parking routes. This is the route leading to my first parking lot here. And the parking direction is forward. And the next one, this one, leading to the same parking lot, but the parking direction is reversed. And there is a new attribute which is called relative flow for the same parking lot. And here you can specify the relative flow. So the amount of vehicles parking forwards and reverse. I will switch to 3D mode and start the simulation. So we will see some vehicles coming and parking. And as you can see, we have vehicles parking in reverse and parking forwards. So both types, because I specify 50% backwards and 50% forwards. So this is brand new. This is not in the current VISSIM version right now, but that will come very soon. And that will make it even easier to manage all the operations with loading bays. Okay, I go back to presentation. For pickup, drop-off operation or 3D static models manipulation, like opening and closing the barrier, I recommend taking a look at the examples provided within the installation. Especially, I want to point on the powerful attribute modifications you can use to change the attribute value of an object. That is a very mighty tool in your hands. A few words about pedestrians in VISSIM. Basically, you have two options how to model them. They can be modeled as vehicles, which means it's lane-based, pedestrians working on the lanes of links. That is interaction with vehicles, but no interaction between pedestrians set by default. And this is suitable for simple modeling, like pedestrian crossing could be used. And then we have the advanced option, the VisWalk pedestrians, which is based on advanced social force model for pedestrian interactions. And here pedestrians walk on areas instead of links. And there is a full interaction between pedestrians and interaction with vehicles on links. So complex modeling scenarios as possible, and it's much more realistic. The basic building blocks for the modeling are links and connectors on one side and arrays, ramps, and stairs on the other side for pedestrian modeling. For interaction, the conflict areas can be used and priority rules. And in this case, you can use the links as pedestrian areas. So you can set an attribute which says that that link will be a pedestrian area. And pedestrians can use a link in both directions and interact with vehicles. Also, stop signs can be used for the vehicle type objects only, and signal heads for both of them. There are several 3D models available in VISSIM for pedestrians, like for individual pedestrians, you have man, woman, child, wheelchair. There are also models with luggage. If you would like to have something special like a sitting pedestrian, then you would need to find a suitable model somewhere like in SketchUp warehouse, or you could create it by yourself. And in the simulation, you can switch from a walking pedestrian to a sitting pedestrian. That would be possible, and I will show it in a small example. Regarding the social groups, you could have a mother with child in the simulation that's available. What is not possible to see family going together, or a group of friends, that's not available yet. And the equipment like shopping carts or airport trolleys or mobile beds in hospitals or anything else, that is possible, but there is no special behavioral model for non-standard models. So you can visualize that quite easily, but for the interaction is better to use or to let the pedestrians to work on links like the vehicles do for this type of 3D models. So let me go to VISSIM. I have a small example here. I will just start a simulation, and you will see pedestrians coming to the bank, and then they are converted into sitting pedestrians there. Other pedestrians are just going through, or take a break there, talk to someone else, or they make a break in front of the building. or they are going to buy a newspaper, so they stay in a queue. And now I will pause the simulation and switch to 2D. I want to show you something with these three pedestrians waiting here as a group. So when I click one of them, then I can check and attribute a new one we implemented within the more project, which is called dwell time. So I will just edit into my quick view. And here I can see how many seconds the pedestrian will wait here. When I click on another one, this is another value. And here, this is another value. But what I can do, I can select all of them and I can set the dwell time to 0 for all of them. And afterwards, let me go to 3D again. And now I will simulate step by step. All three pedestrians leave the waiting area there at once together. They don't stay together while walking, but they can leave the waiting area or a room or anything else you can imagine at the same time. And that is possible with a new attribute dwell time and setting it to 0. I did it manually, but you could do so by using attribute modifications. And here in the list of attribute modifications, you can see few of them. And in this example, I'm using the attribute modifications to change the pedestrian type. That's the target attribute here in this modification. So here I'm changing the object, which is pedestrian in the network, and the target attribute is pedestrian type. And here's my filter or conditions that which need to be fulfilled. So if the attribute, which is called sitting, equals to 1, and if the pedestrian type is not 110 and not 210, because I want to do the change only for a certain type of pedestrian, then this comes in place in action. And this is an if condition saying if pedestrian type is 100, then change it to 110. Otherwise, change it to 210. And this means if it's a man, then change to a sitting man. If it's a woman, then change it to a sitting woman. And this attribute modification changes the appearance or the model itself for that pedestrian. So it looks like they are sitting on a bank, and then later on they are converted back to a working pedestrians. I didn't match the colors of the shirt and trousers for these pedestrians because it's just a demonstration. But this is an easy way how you can change attributes of objects and achieve almost anything within the model. Okay, I go back to presentation. A few words about shared space. So if it's about crossing conflicts, there is a standard solution with the conflict areas and dynamic potential. And this is the solution you can see in the right top corner, where the pedestrians are going through the spaces between the vehicles when they stop. And as you can see, they actively look for an empty space somewhere near. They don't stop and don't stay there. So they are actively moving towards the opportunity. The other possible solution, what you can see here on the right side, is using partial routes, formal-based partial routes. And when the pedestrians in the middle of the corridor recognize the bus approaching, they get a route which take them out of the middle corridor to the side. So that is possible as well. And here on the left, on the bottom, you see a special solution using the COM technology. And here it's about converting the vehicle into group of pedestrians, which allows to interact pedestrians with other pedestrians in the social force model. Okay, next one. We also have some features for social distancing. So if the pedestrians are queuing, then you can set the distance between pedestrians there in the queue. So in the COVID time, it's a useful feature. And similarly, if it's about pedestrians waiting for a public transportation, for a bus or for a train, then on the waiting area, they can